All right, we're back for another Ohio State test review. Today we are looking at standard 8.EE.3. This has to do with operations on numbers in scientific notation. Pretty much figuring out how much bigger something is than something else. We use scientific notation for estimating either very, very large numbers or very, very small numbers. Okay. So remember, for a number to be in scientific notation, for those who don't remember, it has to meet two rules. One, it has to have a leading number. That's the number in front of a decimal. Between 1 and 9. It has to be a single digit number. Okay? And 2, it has to be multiplied specifically by a power of 10. So 10 times 10 to the something. Okay? So let's talk about number estimation. Starting with number 1. A pebble weighs 3 times 10 to the negative 2 pounds. A large boulder weighs 9 times 10 to the 3 pounds. How many times larger is the weight of the boulder than the weight of the pebble? So you have to think about order, okay? Whenever you're asking how many times larger is something, you're always going to go division. And you always want to put whatever they list first in your numerator. How many times larger is the weight of the boulder? So what's the weight of the boulder? 9 times 10 to the negative 3 pounds. So we're going to put that in. Then the weight of the pebble over the weight of the pebble is 3 times 10 to the negative 2 pounds. Now, how you could do this, you could split this up, take care of dividing your numbers here first, and then dividing your powers of 10, or you could just do it all in one go. Okay, so here's how you do it all in one go. First, parentheses, 9 times 10 to the 3. And you ask, why does it have to be in parentheses? Because you want to make sure that the scientific notation is being done first, right? Because it's order of operations. If you don't put the parentheses when you go to divide by, say, 3 times 10 to the 2, 10 to the negative 2, it might mess up things, okay? So whenever you're dealing with numbers in scientific notation, always put them in parentheses. And just hit enter. 300,000. 300,000. Answer done. Okay. Next question, two-parter. The masses of two animals at a zoo are described where B and C are integers. The mass of an African elephant is 6,125,000 grams, or about 6 times 10 to the B grams. The mass of a silverback gorilla is 185,000 grams, or about 2 times 10 to the C grams. What are the values of B and C? Okay. So, let's talk about estimating numbers. Okay. 6,125,000. Okay. What you're going to do first is you're always going to round to the number farthest to the left. Okay? So my number farthest to the left is 6. 6 is either going to round up or down based on the 1 next to it. Okay? So it's going to be based off the 1. Remember the rule. 5 or above, give it a shove. Okay? This 1 is less than 5. So your 6 is going to round down to 6 million. Meanwhile, your silverback gorilla we're going to round the number all the way on the left, either up or down, based off the number next to it. 8 is bigger than 5, so we're going to round up. That means the 1's going to go up, and everything after that will be zeros. Now, when you're estimating numbers in this fashion, how you're going to do this is you're going to put a decimal point after your number all the way on the left. Okay, so for 6 million, you're going to put your decimal point here. And for what your exponent will be, you just count your zeros. 1, 2, 3, 4, 5, 6. So that's 10 to the 6. Here, you're going to put your decimal point next to your 2. And you're going to count your zeros. 1, 2, 3, 4, 5. So this would be 2 times 10 to the 5. So your value of B being here, would be 6. And your value of C being here, would be 5. Part B. Using the estimated values, the mass of the African elephant is about 3 times 10 to the m times the mass of the silverback gorilla, where m is an integer. What is the value of m? So we're just going to take these numbers that we estimated. 6 times 10 to the 6, 2 times 10 to the 5. And again, you could just put this in the calculator, or you could split it, right? 6 divided by 2 is 3, which matches what we have, so that's good. Times 10 to the 6 divided by 10 to the 5. Now we go back to our exponent rules, our quotient rule, right? X to the m divided by x to the n is equal to x to the m minus n. So this would be times 10 to the 6 minus 5, which would be 1. So your value of m would be 1. And that's it. All right. Well, let's go to our next question. Which expression is equivalent to 0.0005? So now we're dealing with an infinitely small number. Okay? Well, not infinitely small, but a very small number. How you're going to do this is you're going to move your decimal point to the right of the first non-zero number. And then just count how many spaces you had to move. 1, 2, 3, 4. So 5 times 10 to the 4. But since this is a very, very small number, this is going to be negative 4. Okay? When you're dealing with numbers that are bigger than 1, they have positive exponents. When you're dealing with numbers less than 1, you have negative exponents. Okay. So this would be 5 times 10 to the negative 4, which is choice B. All right. Next question. An incomplete sentence is given. The value of 2 times 10 to the 14 is blank times bigger than the value of 4 times 10 to the 6th. What number correctly completes this sentence? Okay. So we're going to divide, because that's what we do in these situations. 2 times 10 to the 14 divided by 4 times 10 to the 6. And let's put this one in the calculator. 2 times 10 to the 14. Again, making sure we're in parentheses. Divided by 4 times 10 to the 6. Whoops. We're going to hit enter, and it's going to tell us that number. 5, 1, 2, 3, 4, 5, 6, 7. 5 with 1, 2, 3, 4, 5, 6, 7 zeros. Otherwise known as 50 million. Especially when you're working with numbers like this, you always want to make sure that you are counting your zeros, double count your zeros, triple count your zeros, make sure you have it right. Or if you wanted to write it in scientific notation, you could write it as 2, 3, 4, 5, 6. You would 5.0 times 10 to the 7. Because you stick your decimal point next to the 5, count your zeros. 1, 2, 3, 4, 5, 6, 7. Either way works. Okay. The radius of a fluorine atom is 5 times 10 to the negative 8 millimeters. The radius of a strontium atom is about 2 times 10 to the negative 7 millimeters. But how many times larger is the radius of a strontium atom than the radius of a fluorine atom? So they're listing strontium first, so we're going to use that number first. 2 times 10 to the negative 7 over the fluorine atom, which is 5 times 10 to the negative 8. And again, calculator. Use that calculator. Times 10 to the negative 7 divided by 5 times 10 to the negative 8. And you hit enter and you get 4. 4. That's it. 4. Just use your calculator. Use your resources. Let's go to our final question for this video. Which expression is equivalent to 0.00007? So we're going to do this the same way we did the other one. I'm going to rewrite it here so it's a little bit more spaced out and bigger. There are 1, 2, 3, 4 zeros, and then 7. You're going to stick your decimal point after the 7. You're going to go 1, 2, 3, 4, 5. 7 times 10 to the 5. But remember, this is a very small number, less than 1. So it's going to be a negative exponent. 7 times 10 to the negative 5, which would make it answer A. All right. So that is another standard down. So I hope this has helped you prep. And I'll be back with more standards. And thank you for watching, and good luck on your state test.